I was just going to basically explain what we've done, where we are at the moment, and hopefully where we're going. To sort of start off with, I mean, really, my initial thought was, what on earth are we doing producing a whole load of piled up plastic from the 3D printers? It'd be nice to do something with it. So that's where I started. And I started off with a sort of a vague version of an extruder. And people can probably remember me vaguely sort of bubbling a load of old plastic out the bottom. And when we got it too hot, it just became incredibly brittle and useless. Initially, I got like little very fine bits out, made it a bit thicker. Really was a complete waste of time. It never managed to make filament that would ever go through the thing again. I've just recently been in touch with, I know a professor at the Suffolk University, and they apparently have got a nice extruder gadgetry. So it shreds, puts the plastic through, churns it out, costs £9,000 from America, and they can't get it to work. So I'm beginning to think trying to get extruding plastic out again and then using it in the 3D printer sounds nightmare, unlikely to happen. So having done that, the next thing is, right, failed miserably, what do we do next? Barney very kindly mentioned precious plastics to me. I was saying it was on Slacks, and he said, have I seen precious plastic? I thought, well, no, I haven't. So I visited their website, had a look at there, and they had the machines. Andy's sort of got the instruction-y bits from them, the files, and hence Munchy machine over there is sort of, Andy's done his whiz sort of welding and bits and pieces, and we now have a machine that will crunch up plastic and create something that we can then use from that. So hence the shredder. Precious plastics tends to use things like ovens and bits and pieces or anything really. Had a look on YouTube, see what they do. Ended up having a go at just putting plastic between a couple of metal sheets in the oven, half an hour, 200 degrees, take it out, put it into a press, give it a good old shove down, and we started to produce, where are we? There you go, some bits of plastic. So they're the sort of, just from a sheet of plastic. So do have a look at those later. Those are polypropylene. So they seem to be quite useful. I initially thought it would be nice to make some stamps to stamp it with. Failed with that at the moment, but hopefully that's another project we need to do, is to have something so that we can actually stamp it so it has the right symbol on it, so that people then know what it's made of, so we can go from there and it can be recycled again. And I'm assuming that heating it up, crunching it, shredding it, heating it up, crunching it is a possibility, and that won't degrade too much with what we're doing. I mean, as a chemist...
Yeah, it's probably, you can go through quite a few cycles, I suspect. You will slowly break the polymer chains down and it will get...
I mean, I think that
density polymer that is less, a bit less, it'll have less tensile strength and it will...
and I think that's what we found with the PLA. Probably. The PLA just seems to become awful when you heat it up.
I wonder if that's a rheological effect, because you know the direction that the polymer chains are aligned in has a big effect on the flow and properties of it. And I don't know how they commercially extrude it, whether it's melt extruded and stretched so that the polymer chains align in some way when they manufacture commercial filament. I don't know.
No, don't know.
Not stretched.
It's not stretched.
No, not to my knowledge. But
or whether there's any, if they put any plasticizers into it, maybe to.
But most of them seem to say when you're reusing it, chuck some new stuff in with it.
Mm-hmm.
if you're going to try and do that, which sort of defeats the object slightly, really, doesn't it? So the sort of between two sheets, 200 degrees, 20 to 30 minutes, remove and press. Alan sort of provided a nice book press. We got some dog bowls that Dan managed to sort of produce, sort of give us, and they've since been. They've since been adapted slightly with a bit of welding. So that gives us basically a press for creating the bowls. And if you want to have a look at the bowls, we've got plenty of bowls around there. Initially, I did use just sort of a hand press type thing, just to sort of try it out, really. The plastics we've been trying to use HDPE. I suppose the other question is, when we're heating this up, are we going to have problems with toxic fumes? Do we need to worry about that? But
I think HDPE, if you actually, milk bottles are almost pure virgin HDPE, so it's a pretty safe, pretty nice source, I would say. And providing you don't overheat it outrageously, I think you're pretty safe with that. To be honest, I mean, I've done those kind of experiments in the oven at home, and it's fine.
I mean, HDPE, you seem to be able to get it into a nice big lump, so you can then machine that. So that sort of can presumably be quite useful. I have had a go at machining it slightly today. So the idea is to try and create little pen bits and pieces. So that's just using a wood lathe. So it's, that has potential. So that's quite useful. We did try laser cutting it. Nick had a go at laser cutting it, and it just remelted together again, really. So that was not very helpful.
Is that a problem with laser cutting in general? I mean, or is it something particular about the recycled stuff that's different?
You can't,
I think
it's HDPE doesn't laser cut.
Doesn't seem to laser cut, really. The polypropylene did laser cut, but then we managed to get much thinner pieces. And the thin polypropylene, you seem to be able to sort of cut with the laser cutter. So if anybody wants to have a go with that at some point, do. And it flows much better together, it seems, the polypropylene. And that's more things like yogurt pots and margarine tubs and things like that. And you get a nice, it's a nice, flexible, useful sort of product. So that's quite good. PET, that's mainly your drink bottles, are a nightmare. The shredder doesn't like the necks because they're like concrete, aren't they? They're just terrible things. It seems to stick to the metal sheets in the oven, so you then have to sort of take it out and sort of clean it all up again. So it's not easy. Really don't know what we're going to do with that. But we got quite a lot of that, sadly.
Can you find out about the double heating?
It's because there's water in it as well, and also if you're getting it hot enough.
Hydrate it, dehydrate it.
So it sounds as though we've got to try and heat it up to a certain temperature, drive the water out of it, then heat it up even more, and then crunch it together.
Is that water actually going into the material?
I don't know.
What's our chemist say? It's hygroscopic, so it absorbs water.
It's not. It's a very good moisture barrier. Actually, that's what it's used in thin film in packaging. So I don't think the water's really going into the polymer too much, but maybe you get a adsorbed
like
layer
of
of it on the surface of the material that I don't know. Something I'd have to look into.
Let's say polypropylene we've done well with. HDPE we seem to have done well with. So where next? Well, the injection machine is heating up today for the first time. So Andy's been working on that. That's hopefully the next thing then will be to make moulds to go with that. So anybody wanting to make their own mould, feel free to have a think about that. Larger oven we've got now, so maybe we'll produce bigger sheets, I don't know. It'd be nice to produce some items to sell, maybe demonstrate the machines and things like that. And then once we've sort of got ourselves up and running properly, then hopefully increase donations of plastic and into the project and so on. But what I wanted to try and show is that lots of people have had inputs into what we've been doing. I mean, lots of people have sort of come along and done little bits and pieces. Andy's been major machine builder. I've sort of tried to push it as much as I can and try things out as much as I possibly can. So hopefully we'll be able to sort of move on from here and do other things. And if you want to get involved, then there is bits of plastic lying around all over the place. If you want to have a trial, then just ask and I'll give you a lump and you can have a go with it and see what you can do. I mean, there's all sorts of ideas with it, but I mean, people have made things like mallets out of the large lumps of plastic and things like that, and it's not that difficult to do. The sandwich press that I've just bought like a sandwich toaster thing, and that is very good for heating up plastic and pushing it together, and then you can end up with a lump, and then you can actually machine it. So I mean, that's really where we're sort of looking to see what we do next, really, and what we can do. But any questions on what we're up to? But I don't know.
I just wondered if anyone's tried vacuum forming, because that looks like it ought to vacuum form now. You made a nice thin
we're going to try
uniform
doing
sheet
some like press thermoforming. So just use two halves of mould and press them together when they're hot. It's getting a big enough sheet of material to do vacuum forming and building a machine to do it with. So, something worth trying.
Yeah.
It's also got the potential to interest people outside of the Hackspace in terms of projects and funding, and sort of. I mean, I'm not suggesting we want to go as far as offering to recycle people's plastic, but I think the learning from it could be of great interest too.
Well, there's also, I mean, there's people on precious plastic who are very interested in the UK on what we've been doing. I'm on the Facebook group there, and people have asked how we've done various bits and pieces, so I've explained to them. Because some of the precious plastics machines are, how can I put this, industrial machines. You can't plug them in, they're too big to get through the door. The latest set of machines are a joke, I think.
Three-phase
Yeah.
machines and huge as well, 2 meters square. The sheet press.
I mean, that's moving to small-scale industrial recycling facilities, and it can make sense. But
what you're doing as well, though, is kind of highlighting the usefulness of the material, right? So, like that lump of plastic there used to be milk bottles, and it did that job very, very well, transporting milk. But actually, the properties of that material being that it's has low friction to it, readily available in blocks that you can machine, means that actually people can start using it or seeing it in different contexts of this was a milk bottle, now it's a bearing surface for this machine or for this bit of kit, and actually genuinely reusing it for different things. Spark thoughts on actually what the property of that material still has even after it's transported the milk for you. So I think that's really exciting.
I would agree with that, and I think it's really important as well, because if you can generate the idea that there's value in a material, then it stops being waste and starts being raw material again, and that's very much the thinking that's being used behind lots of projects that are going on. I highlighted the Southeast Asia problem, and there's a lot of UK aid money sloshing around right now to try and help developing countries solve their enormous plastic litter problems. And I think this kind of idea is really interesting for that environment, because they don't necessarily, I mean, one of their big problems is they don't have the infrastructure for regular municipal waste collection. So they just stack it up somewhere, and then it rains a lot, or it blows a lot, and it all disappears.
It scatters.
It scatters, and, well, it all goes in rivers, basically, which leads to these huge clogged up river problems. But I'm thinking, you know, if people had tools like that are very simple and relatively small, you can do that for quite a small amount of money, and you can reduce that repurposing, remodeling down to a local level, where, you know, that could be a 1 village scale activity, or maybe it could be a 5 village scale activity,
Bit
or
like having
maybe it could be on the back of a pickup truck that can go around village by village once a month and chunk up all their waste into something that they can then reform into, I don't know, what's that? Is that a shingle? Is that a roof tile? Is that the bottom of a produce box? Is that it's got to be something that they could make that would actually be useful to their lives and their situations.
Yes, I think that's a much better idea than some of them are just creating like key fobs and things like that.
Yeah, well, they don't need key fobs.
And,
they need
and
something
then they're
that,
selling those to the tourists.
Yeah. Well,
who are then,
that's-
what are they doing
yeah,
with them?
that's fine.
Hopefully
I mean,
taking them home to America or whatever, and then, I don't
Yeah.
know.
I mean, for us, that's
Sticking them
fine.
there, like.
Yeah.
And you know, for sort of beach tourism, maybe that's
And,
A
and
bit of
that's
that
what some
is-
of them are doing,
yeah, a
is
bit
the
of that
beach tourism
is
type, getting
yeah.
rid of them that way. But if they could actually turn them into something
useful.
useful,
Yeah,
I
I
think
mean, a
that
lot
would
of
be
the,
much better.
you know, most of these villages are in sort of,
Mm.
you know, very rural areas where tourists don't go.
yes.
Typically, they don't have that option. But surely it can be turned into something that they can use. Or if you turn it into that, you can pack, you know, 20,000 of them in the back of a truck and take them somewhere else where they can use them. Whereas if it's all, you know, if it's still
Air.
bottles,
Yeah.
it's all air.
Yeah.
And the problem is there's a huge global CO2 cost to transporting all that air around, because it just has a ridiculous amount of volume.
Yeah, because you can actually sell the shreddings to industry. The precious plastics
I mean,
is what.
Yeah, there's
Yeah,
lots of post-consumer plastic stuff, and you can buy lots of bottles that are, I mean, M&H Plastics in Beccles, for instance, they put 25% post-consumer plastic in quite a lot of their bottles. There's an issue with food because it's not.
How much of an issue is that? I mean, if we really are clean with our milk bottles,
Yeah,
could
well,
we make something which is you could put water in a drink from?
you probably can. I think it's much more fear
Yeah.
than reality,
Yeah.
most
You
likely.
can't put a guarantee food safe
They-
label on
Yeah.
it if you're selling it.
And the problem is, yeah, to check it and verify it on a regular basis would add a lot of cost to it. And the whole reason they use it, of course, is because it's very, very cheap. So I
But
think
for our-
that's.
I mean, is
that's-
there anything we could chemically do to it to say, make it safer? Surface.
Yeah, I'm sure there is. But
Treatment.
do you want to put those kind of, anything that kills biology
Yeah.
is by kind of definition toxic.
Yeah. But then
Yeah.
the point
So
is,
you could use
wanna make something
UV
that becomes,
sterilisation or something like that.
okay, that'd
maybe.
probably be That's,
I mean, you could wash it, but then obviously
Yeah.
then you're reintroducing the particle problem
Yeah.
because you
Yeah,
have
so-
wastewater full of plastic.
Out of the plastics that you've got on there, what do they do on an industrial scale for recycling? Where do they all end up? Are they all recyclable on your list? You had HDPE, milk bottles. Where do they end up?
I think some of them are recycled, aren't they? But
They're recycled into things like park bench slats and the black plastic bags they use for refuse collection and stuff like that.
Yeah,
It
So
seems like there's not
low
enough
density.
of products that are made from recycled things for all of the plastic that we must have recycled by now to have been made
There
into.
are. You can buy. I mean, we were talking about shower lining earlier on,
Oh, yeah.
and you can buy stuff that's used for worktop showers, that kind of thing. But it's very expensive. I
Yeah.
mean, you know, it's
You can buy
because
like
it's in the
cardboard.
sort of designer range of things, and compared to say any other thing you might think of to line your shower with.
Yeah.
But you know, if we could make cheaper versions of that kind of thing, that would be, you know, apart from scouring it.
There's also the potential for your sheets there, Brian, to be used to repair other plastic things. So we've just started a little foray into plastic welding as well, and mending things that are made of plastic with plastic to try and give them a second life. And I suppose in theory you could use that as patching for that.
Yeah, I brought my wormery in that the rats had a go at. Yeah, so that had a hole in it, and I just patched it up with a bit of plastic, and we've got a plastic welder, and repaired it, and the worms are happily working away again. Although they're captivated in the wormery, so it's probably not.
It's fair to say we've got a little bit of a learning curve to go on the plastic welder.
The
wormery,
quality
whilst
wasn't
functional.
You
like
wouldn't
a new
want
one,
to
was
look at it
No.
from an
All right,
aesthetic
the worms.
point of view. Let's put it that way. But the worms don't care.
Yeah,
They
luckily,
don't care.
so.
Great. Have we got any other questions or thoughts or input? Anybody want